So my dear students, so today we are going to start with the stereoisomerism. So this is also very interesting topic, and this is the continuation of the previous lesson, that is the isomerism. And this is the particularly stereoisomerism, that is a stereochemistry, and that it involves the carbon compound, the stereochemistry here. So we will understand what is actually this isomers. So you know that particularly isomers are nothing but the same molecular formula, but there is a difference in their whatever the structure, functional group, everything there is a different, but the molecular formula is same. So let us understand the stereoisomerism here. So first of all, you need to understand these two here, isomers. So I will tell you the isomers are actually classified into two types. Isomers are actually classified into two types. So one is structural isomers, one is structural isomers, and the second one which is stereoisomers. So what is this? So structural, what is actually this structural here? So structural, it indicates nothing but very simple, you can write like this. So let us write. See here, we'll write here. See here, the molecular formula. See, observe the molecular formula here. So you can see here the molecular formula, that is, here there is 1, 2, 3, 4 carbons are there. Here also 1, 2, 3, 4 carbons are there. That means here C4, I can write here C4 and hydrogens. So there are 3 hydrogens here, and again there are 2 hydrogens here, 2 hydrogens here, 3 hydrogens here, also 3 hydrogens, 2 hydrogens, 2 hydrogens, 3 hydrogens. That means here you can count the number of hydrogens for the both of the compounds, that is, so 3 plus 3 6 and 6 plus 4 10 and O. So this is the molecular formula of both these two compounds. So like this is the functional group isomerism. I think, but you can take many of these things. So let us, I will tell you such example. So let us write like, see this. So see the position of the double bond. So there is structure is different, but the molecular formula is same. So this is particularly the structural isomer. But the stereoisomers are nothing but these are generally like enantiomers, diastereomers. So you know that. So very simple. The structure is completely similar, and the molecular formula is similar. But the difference in the stereochemistry. So that means, so let us understand here. So I will take one of the example, that is CHO. So I will remove all these things. So stereochemistry, stereoisomers. Stereoisomers. So let us take one example like CHO, CH2OH, and this is OH, and this is H, and I can write this is CHO, CH2OH, and here I will write H, and here write OH. So what is the difference between these two things here? So this first one, so you can easily understand that the OH is, which is right side here, and but here it is left side here. So this is actually called L-glyceraldehyde. L-glyceraldehyde, and this one which is called D-glyceraldehyde. D-glyceraldehyde. So this is a D-glyceraldehyde, and that is L-glyceraldehyde. That is left side, and it is the D, that is dextrorotatory, and that is a levorotatory. Like this stereochemistry will be different like this. And you can take the glucose. So I will tell you the glucose structure like this. CHO. So I can write the glucose structure will be like this. CH2OH. OH, OH, H, OH, H, OH, H, H. So this is the structure of D-glucose. This is the structure of D-glucose. So this D-glucose, actually this is present in the generally in the whatever the glucose. So generally the athletes will take this glucose in the form of this D-glucose only. So because the OH which is on the right side, if it is left side, then it is L-glucose. So that is the stereochemistry here. So the stereochemistry is very important thing. And for this stereochemistry, we need the term which is optical activity. So we need to know first the optical activity to understand the stereochemistry. So what is optical activity? We'll understand that, and then we will see the stereoisomer, the classification and everything. So what is an optical activity? So optical activity. So optical activity is something it is related to the light and the activity. So it must active. So what is an active? Let us see the optical activity here. So nothing but see here, you can easily understand the optical activity of a particular sample. So optical activity is nothing but, so whenever we intense a particular light and a particular sample, this is a sample here. Sample is nothing but our molecule. And the light which is intense on this particular molecule, which can be rotated towards to left side or right side, then it is called optical activity. Optical active. So very simple here. So very simple. The light which is passing through a sample, it must be rotated towards to left or right, then it is called optical activity. So let us understand clearly with this. So the light which is not exactly light, this is actually called plane polarized light. Plane polarized light. So plane polarized light here. So plane polarized light, what actually it indicates? So this particularly optical activity in this, a plane polarized light is used. So I will tell you exactly the light, the direction, everything. So see here first. So generally the light which is actually called EMR, nothing but electromagnetic radiation. Electromagnetic radiation. And this electromagnetic radiation actually it will vibrate in different planes like this. It may propagate in different directions like this. So particularly light అంటే ఇలానే వస్తున్న రూల్ లేదు. సో ఇఫ్ ఇట్ ఈస్ కమ్ త్రూ ఏ వేవ్ లైక్ దిస్, లైట్ ఒకవేళ ఇలా వస్తుంది అనమాట, ఇలానే వస్తుందన్న రూల్ లేదనమాట. ఎందుకంటే దెర్ ఇస్ అన్ ఎలక్ట్రిక్ కంపోనెంట్ అండ్ దెర్ ఇస్ ఆల్సో, సో ఐ విల్ డ్రా ద electromagnetic radiation. See here. So you can see here. So this is certain like electric component, and if you write the magnetic component, it will be looks like this. So they are perpendicular with each other like this. See here. So the electromagnetic radiation, in which it will propagates in different planes like this. అంటే ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్ ఇట్లా ఒకటే ప్లేన్ లో ఇలా ఎగ్జాక్ట్ గా ఇదే డైరెక్షన్ లో ఇలానే రాదు. సో ఇట్ విల్ వైబ్రేట్ ఇన్ డిఫరెంట్ ప్లేన్స్. సో డిఫరెంట్ ప్లేన్స్ లో వస్తుంది, డిఫరెంట్ ప్లేన్స్ లో వస్తుంది. సో నేను ఒక శాంపుల్ తీసుకున్నా, ఈ శాంపుల్ కి నేను లైట్ పంపిస్తే ఈ లైట్ అనేది మనకు లెఫ్ట్ రైట్ తిరగాలన్నమాట. సో లెఫ్ట్ సైడ్ తిరిగితే, రైట్ సైడ్ తిరిగినా దాన్ని తిరిగితే దాన్ని ఏమంటామంటే ఆప్టికల్ యాక్టివ్ అంటాం. ఆప్టికల్ యాక్టివ్ అంటాం. బట్ ఇక్కడ తిరుగుతుందా లేదా అని ఎట్లా తెలుస్తుంది అంటే, ఫస్ట్ ఈ లైట్ అనేది ఒకటే ప్లేన్ లో ఉండాలి. మల్టిపుల్ గా ఇష్టం వచ్చినట్టు తిరుగుతా ఉంటే అది ఎటు తిరిగిందో మనకు తెలియదు. సో అందుకే ఫస్ట్ లైట్ మస్ట్ బి వైబ్రేటెడ్ ఇన్ వన్ ప్లేన్, ఒకటే ప్లేన్ లోకి తీసుకురావాలి. సో దాన్ని ఏమంటామంటే ప్లేన్ పోలరైజేషన్ అంటాం. ప్లేన్ పోలరైజేషన్ అంటాం. సో దిస్ క్యాన్ బి అబ్టైన్డ్ బై ఎ polarimeter. So that we will see in the later session, the polarimeter. But you have to understand one thing only. So first the light is actually plane polarized. So light తీసుకొని, లైట్ అంటే ఇట్లా మల్టిపుల్ డైరెక్షన్స్ ఉంటది, ఇట్లా మల్టిపుల్ డైరెక్షన్స్ ఉంటది. సో ఈ మల్టిపుల్ డైరెక్షన్ అండ్ సింగిల్ ఒకటే డైరెక్షన్ తీసుకురావాలి. సో ఒకటే డైరెక్షన్ అంటే ఐ విల్ టేక్ ద లైట్ ఇన్ దిస్ డైరెక్షన్ అండ్ ఐ విల్ ఇంటెన్స్ అనే పర్టికులర్ శాంపుల్. ఈ శాంపుల్ కి ఇంటెన్స్ చేస్తే దిస్ లైట్ మే బి రొటేటెడ్ ఇన్ లెఫ్ట్ సైడ్ ఆర్ రైట్ సైడ్. లెఫ్ట్ రైట్ తిరుగుతుంది. సో లెఫ్ట్ రైట్ తిరిగితే దాన్ని ఆప్టికల్ యాక్టివిటీ అంటారు. సో దట్ ఈస్ కాల్డ్ ఆప్టికల్ యాక్టివిటీ. అండ్ ద ఆప్టికల్ యాక్టివిటీ క్యాన్ బి మెజర్డ్ బై ద ఇన్స్ట్రుమెంట్ విచ్ ఈస్ కాల్డ్ polarimeter. Polarimeter. So the polarimeter is nothing but it will measure the optical activity of a particular substance. So polarimeter, it will measure the angle. So it will measure the optical rotation angle here. So it తిరిగినప్పుడు ఎన్ని డిగ్రీస్ తిరుగుతుంది? It may be plus 13 degrees or minus 15 degrees. 15 మైనస్ అంటే లెఫ్ట్ సైడ్ తిరగడం, ప్లస్ అంటే రైట్ సైడ్ తిరగడం. ఎంత తిరుగుతుంది అని మెజర్ చేసేది polarimeter. If it is zero, then it is called optical inactive molecule. So very simple. the plane polarized light. So this is called plane polarized light, single plane polarized light, which is intense on a particular sample, and this light will be rotate towards to left or right, which is called optical activity. So left or right or rotate చేస్తే then optical activity andam. So the phenomenon is called optical activity, and the isomers which they are called optical isomers, and this can be measured by the polarimeter, the optical rotation angle which is called optical rotation, and the angle which is measured by the polarimeter instrument. So if it is zero, if this light which is exactly like this ఇలానే ఉందనుకోండి, దాన్ని ఆప్టికల్ ఇన్యాక్టివ్ అంటాం. Optical inactive అంటాం. So that is optical activity. So you have to understand this thing here. So once again I will tell you one thing. So the plane polarized light which is intense on a particular sample. So if it is this sample, and it may be rotate towards to left side or right side. So I can write this three directions like this. So let us understand here. So that it is optical active. So if it is moving toward to right side, then it is actually called dextro-rotatory. Then if it is rotating towards the left side, then it is called levo-rotatory, left side like this, and the right side like this. So like this is called optical activity. But this can be achieved by using only polarized light. ఈ polarized light ఎలా వస్తుంది అంటే, సో దీనికి ఒక ఇన్స్ట్రుమెంట్ ఉంటుంది, సంథింగ్ లైక్. సో ఫస్ట్ మనం లైట్ పంపిస్తాం నాన్న. దిస్ ఈస్ ద లైట్. సో లెట్ us say this is a light, and here it is vibrates in different planes like this. So like this, the light which is vibrates in different planes, and we will use a prism which is called Nicol prism అని ఒకటి యూజ్ చేస్తాం మనం. ఈ ప్రిజం పంపిస్తే ఈ లైట్ అనేది సింగిల్ ప్లేన్ గా వచ్చేస్తుంది అన్నమాట. సింగిల్ ప్లేన్ అంటే లైక్ దిస్. సో 1 minute. So it will vibrate now in a single plane like this. So this is only one plane. So before this, which is called unpolarized light. This is unpolarized light, and this is called polarized light. Polarized light. And this is also called PPL. That is plane polarized light here. So single plane polarized light here. So this can be intense with the sample. మన sample పంపిస్తే ఈ light left or right తిరిగితే దాన్ని optical activity అంటారు. So this is called optical activity. And this rotation of this plane polarized light which is called optical rotation. And what is a specific rotation? There is a term which is specific rotation. Specific. So there is a fixed values are there. So generally the rotation is indicated with a symbol like this, alpha like this, and this is the temperature, and this is the wavelength, and this is nothing but observed angle of rotation, observed angle of observed angle of rotation by C into L. So what is this specific rotation? So మనం లైట్ తీసుకున్నాం నాన్న, ఓన్లీ సింగిల్ ప్లేన్ లో రొటేట్ అవుతుంది, ఓన్లీ సింగిల్ ప్లేన్ లోనే వైబ్రేట్ అవుతుంది, అండ్ వీఆర్ ఇంటెన్సింగ్ విత్ శాంపుల్. ఆ శాంపుల్ అనేది ఒక ఇన్స్ట్రుమెంట్ తీసుకుంటారు అనమాట. సో ఆ ఇన్స్ట్రుమెంట్ ఏంటి అంటే పొలరీమీటర్. ద ఇన్స్ట్రుమెంట్ ఈస్ కాల్డ్ పొలరీమీటర్. ఈ పొలరీమీటర్ లో ఈ శాంపుల్ తీసుకుంటాం, అండ్ ద శాంపుల్ విచ్ ఈస్, ఈ శాంపుల్ మనం తీసుకున్నప్పుడు ఎంత తీసుకోవాలి శాంపుల్. సో ద శాంపుల్, ద కాన్సన్ట్రేషన్ విల్ బి C, and L which is nothing but this is the length, and this is the concentration. So concentration of the sample enta తీసుకోవాలి, and length of fixed తీసుకోవాలి. So let us say the concentration which is 1 molar. So I will take 1 molar concentration and 1 liter length of the tube which is we are taking. So మనం length అనేది ఈ ట్యూబ్ లెంత్ అనేది తీసుకుంటాం అనమాట. సో ఆ లెంత్ అనేది 1 centimeter తీసుకుంటాం. let us say it is 1 centimeter, and 1 molar concentration of a particular sample, and if this light is moving towards to right side with the angle of plus 15 degrees అనుకోండి. So this is called specific rotation. Specific rotation, it is nothing but specific, the standard conditions will be maintained here. The standard conditions will be centimeter. So that is the length of the particular sample here, and the concentration which is C, which is equal to just 1 molar like this. That is a specific rotation here. So you need to understand these two things. This can be achieved by the polarimeter instrument here. So this is the specific rotation and the optical rotation. So now see here, let us understand the optical activity again here. So this optical activity, what are the conditions, what are the criterion to maintain for the optical activity? So to need to understand the optical activity, So I'm telling you, whenever the sample is intensed with a plane polarized light, it is sample. So ఈ sample కి plane polarized light పంపించినప్పుడు ఈ sample maybe rotate చేయొచ్చు, చేయకపోవచ్చు. లెఫ్ట్ సైడ్ రైట్ సైడ్ రొటేట్ చేయొచ్చు, చేయకపోవచ్చు. లెట్ అస్ సే ఇది ఏం రొటేట్ చేయకపోతే ఇలా ఉంటది. సో లేదా రైట్ సైడ్ రొటేట్ చేస్తే ఇలా ఉంది అనుకోండి, లెఫ్ట్ సైడ్ రొటేట్ చేస్తే ఇలా ఉంది అనుకోండి. ఇలా ఎటు రొటేట్ చేయకపోతే దాన్ని ఇన్యాక్టివ్ అంటాం. దిస్ ఈస్ కాల్డ్ ఇన్యాక్టివ్. సో మరి ఏ sample molecules inactive, ఏవి active? So which molecules they are optical active and which molecules they are optical active? So how can we know that? So there is a criterion to maintain the optical activity. So criterion to maintain the optical activity here. Optical active undalante anni molecules optical active undavu. So there may be some molecules will be inactive or they may be active. So there are different conditions will be there. So we will understand this. What are the criteria to maintain the optical activity for the particular molecule? So majorly you need to understand these two concepts, that is chirality and the second one which is symmetry. Chirality and the symmetry here. So we will discuss this chirality and the symmetry in the next session. These are the criterion to maintain optical activity. That means here, so మనం sample కి లైట్ పంపించినప్పుడు ఈ లైట్ అనేది రొటేట్ అవుతుందా కాదా, it depends on these two factors here, chirality and the symmetry. So we'll discuss these things in the next session.